All right, good morning everyone. Welcome to my presentation. This is my open source talker. So if you guys, some preamble, if you guys don't know what a talker is, it's for kids with disabilities like autism or Asperger's, where they can't verbalize what they're thinking. And a talker is a sort of medium so they can actually verbalize what they're thinking. And it allows us to communicate, it allows them to communicate with us better. So my name is Harshman. I'm a software engineer. I love building software. We'll be going to Community College of Aurora in the fall of this year. Here are my advisors. I have Miss Willett. She specializes in speech and language and SAS. And Mr. Ackerman, he's a teaching associate professor at the Colorado School of Mines. Here are my support advisors. I have Grant and Ty from CalcVox. I have Jay Al. And of course I have Ryan telling me to use Node. I don't know what that is. So what's the problem? What am I trying to do here? So here are some products here that try to solve this talker problem, having a medium for people to speak. So there's a spectrum to these kind of things. You have tactile talkers and adaptable ones. Ones that have plenty of vocab and ones that give feedback when you use them. And I wanted to go right in the middle here. And that's what WaveSpeak is. So this was a bit of a hard project to make because I'm not really great at hardware. I'm not a designer, I'm not an engineer. I love typing more than this. But so I went for a budget of about $400, which I met. I think I did $390 or something for the bill of materials, for all the buttons, for the display, for the computer. Everything is below $400. So the hardware I'm using a Raspberry Pi for the compute. I'm using 3D printing for all the hardware, building everything. I'm using a little microcontroller for the switch backplane. And I'm using a PCB to build that backplane. So my inspiration started with a product called the Stream Deck. Stream Deck is a macro keypad that allows you to set up little macros and stuff on your computer and access different things with the display. So I started out pretty ambitious with my first design, but after I actually chose my display with all the features I wanted, I got a little bit more reasonable with my design, and I arrived on this design with a communication visor. So that's where the words will show up, and then there's all the vocab. So the biggest issue I ran into was getting tactile user input. I'm not good at compliant mechanisms. I don't know how to design plastic that clicks when you push it, or like that kind of stuff. So I'm going to be using this thing. This is a surface mount button. All it does, you push it down, shorts out some electricity, and it works. So here's the schematic for the backplane. So this is what handles all of the user input. Essentially all it's doing is scanning through all of these columns to see if this button is connecting into a row. And then it will send a signal out from this microcontroller out to the tablet computer. That little thing right there is very important. That's going to come up in software later. So after I designed the PCB, I ordered it and I soldered it. It took me about 20 minutes of soldering and then 30 more minutes of fixing my mistakes. A couple of them melted, a couple of them shorted out. Heat is fun. So the biggest design was the buttons of how they were going to lay out. So all of them are designed with a tab that can also puzzle piece on the X and Y plane. And it will interface right on top of the button, just like that. So when you click them, it will give feedback. So one big issue, one glaring issue, they have to be clear so you can see the image, the display behind them. So my first naive approach was epoxy. I thought that'd be easy. It was not. So here's my first failure. I printed it using TPU, which is a more flexible material, which would allow me to, I thought, would break out the mold. But my TPU was a little moist, so it caused gaps and bubbles in the print. So when I poured them, I came back out to a puddle around my mold. So my next naive approach was a cast. Maybe that would work. So I set up a little cast, I got some clamps set up, I let it sit for about 14 hours, and came back, I gently removed it from the cast, and after that, I got some so-so results. If you can see right here, They're not very clear. You can still see me holding it, so it wasn't the best result I was looking for, but it was still a button. And the next big issue was the tab wasn't working. The tab, the epoxy didn't cure all the way, and the tab right there would flex as you tried to push it, and it didn't give a tactile click feedback when you would click it. So, compromise. I went ahead and just put some negative space in there, and this is just, as much as I hate that T part getting in the way, that's the best I can do right now. So let's get into the software, the more complicated part. So this is built using free and open source software. Everything is open source. You can change it to your will. Built on top of Linux, using Tari as my framework. So the first thing I had to program was that PCB, that little switchback plane that handles the user input. I had to implement a key matrix. So this code scans through the columns, checks if there's an electrical signal going through to the rows. This was the code for that. Seemingly very reasonable. I stole it from Complex. So I made a validation test. I soldered it together, threw something together to just test code because I didn't want to pay $60 for a PCB that didn't work. So after that, you can see right there in the console output, I did get input. I was able to push buttons. It would see that I pushed buttons. So I validated it on the actual board, and it did not work at all. Refused to work, and I had no clue why, because when I would short it using jumper pins, it would work. We come back to here, and this is where we learn about electrical current and DC. My code, quite literally, was sending current in the wrong direction. It is the worst bug ever because it's in between software and hardware. So this is the original code. As you can see, it's writing a column to be low and then a row to be high. So fix that, a little bit of a refactor, and it works. So that was about 4 hours of my life I'll never get back. So now we're going to get into the more embedded software about what the user is interacting with. I had a couple requirements for this. I wanted to run on Linux. I needed low-level access, so I didn't want a framework that would restrict my access to the operating system and configuration in it. And I needed it to be performant and lightweight because the Raspberry Pi isn't very powerful. And it had to be easy to build for. So compiling, essentially what it does is it translates my instructions in English, or pseudo-English, into machine code that a computer can run. And this can be a little bit messy sometimes. We'll get into that. So my first candidate was full-page OS. Allowed me to just use HTML, just use CSS and JavaScript to build out the UI. Biggest problem is literally just Chrome. It's just Chrome. And Chrome is built with a lot of security features, so you can't run back-end scripts easily. There's a lot of roadblocks in the way because it's a secure software that is supposed to prevent hackers from getting into your systems and stuff when you open up websites on the World Wide Web. So I chose a framework, Tari, allows me to build fast and easy apps, and then recommended by TikTokBox, by the way. So then my next candidate was Raspberry Pi OS. This is just going to be the operating system that Tari runs on top of. And it worked on my computer, got Tari built, and then did not work. Refused to work. Apparently, Raspberry Pi OS for the Model 3 compiled with a wrong version. Just some package was wrong, did not work, refused to work. So that was a headache for about 2 weeks. So I switched over to Diet Pi OS with the edgiest logo I've ever seen for a software. So this thing's awesome. I love this OS because it follows the principle of simplicity. It comes with nothing. It comes with a little shell, and I download everything I need, which is good because I don't have much processing power over here, so I need as little stuff in my way as possible. So I actually got into building the software. Tari allowed me to build the software really fast because I'm really good at web laying. I'm good at writing HTML and laying stuff out. So I was able to get this done in about 2 days. And the harder part was text-to-speech. Text-to-speech gave me a lot of problems because it would not compile for the architecture. But to get deeper into this, I designed it in HTML because HTML is easily extensible. A lot of people know it, and it's easy to learn, and it's easy to visualize. So when I was building the data structure, you can literally just add files as you please. If you needed to add vocabulary, you can add it in. And it's as easy as just adding a couple lines. It's pretty readable. And then here's some JavaScript that converts that into a usable element in the HTML page. So just to review my timeline. So I expected to get all of this done in 3/4 of a month. That's what actually happened. And my buttons were done yesterday. So I was pretty rushed and strapped for time. I wasn't very great at time management, but I was also stressed about high school and getting good grades. So, any questions?
Why did you go for a cross-compile option instead of having directly on the Raspberry Pi?
So the Raspberry Pi does not have a lot of RAM. So when you're compiling a program, you have to hold a lot of data in RAM because you're holding variable state, you're holding a bunch of syntax stuff. It's tracking English pretty much. So it takes a lot of RAM. So last time I tried doing it, it ran for infinity. It just was frozen on a package trying to compile it, and it was not working. So I had to cross-compile it on my computer that actually had enough RAM to compile it.
So currently it's, you have to plug it into power, right?
Yes.
Do you have plans to, I mean, I know how difficult this is. We experimented with it a lot, but are there eventually plans to have an actual rechargeable battery or even maybe just batteries that can change, like LAs?
Yeah, so there were plans. I did think about this, and I decided not to mess with it because of how difficult it can be. With the Raspberry Pi, there's already been solutions developed, so honestly, getting power to this thing is pretty easy. The only thing is I don't have a guarantee on runtime. And the thing about this is I don't want it getting in the way. The hardest part about designing a product like this is if it gets in the way, why use it? Like, if you're fidgeting with it, if you're trying to mess with it half the time, more than you're speaking and using the product, what's the point? It's getting in the way. So I just decided not to mess with power. I was just going to focus on software. Yeah, that's it.
Do you plan on continuing, like after this month's working on this?
Yeah, I do plan on continuing and making it easily adaptable. The biggest thing about this project is it's not really a product, it's a project. It's completely free and open source. Any of you guys can download it, edit it, change it to your needs, because I believe disabilities come in a lot of different ways, different paths. And to solve them, you need to solve them because you have your disabilities that you know about. So yeah.
Do you have a demo of it working?
Yep. So right now I have 2 versions. So I had troubles compiling text-to-speech. So this doesn't have text-to-speech, this does have text-to-speech. So we have pages of vocabulary that we can scroll through. And let's see if we can hear it speak.
Country cost corner.
So the text-to-speech currently works on my laptop because it actually compiled on the laptop, but it refused to compile for Raspberry Pi for whatever reason. There was some package incompatibility. Apparently they didn't make a cross-compile package for Python. Yeah?
How much cheaper is it than an actual Steam Deck?
Huh?
How much cheaper is it?
Than the actual one?
It's about $200 more. Well, it depends on which Stream Deck you got. So the Stream Deck XL is about $250 MSRP, and the mini one is about $120. So, and the thing about the Stream Deck is it runs proprietary software. You have to use Elgato drivers. You have to use a closed ecosystem. So.
Did you ever shock yourself on accident while making this?
No, that was a different project. That was really funny.
How did you choose the vocabulary?
So I didn't really choose the vocabulary, and I don't believe in choosing the vocabulary. I think this is a tool, and it's a human right that gives you the ability to speak. If you want to say something, I don't believe a tool should stop you from saying something. I believe that's ridiculous. So the reason I made it completely free and open source is if you want to say something, if you want to add your own vocabulary, you can throw it in there. And that's the most important part. This is for the people. This is for your own use, expressing yourself. And yourself can't be censored. I don't believe that it's okay to do that to people. So it doesn't use a set vocabulary. Right now it has a base vocabulary of like 5,000 right now. That's just what I implemented. You can implement thousands, millions, whatever can run.
Other questions?
On the dev version, is there like an add vocabulary?
So I did want to make a tool chain for adding stuff, making it easy to add things, but I had troubles with that because I was focusing on building the core software and I had a lot of troubles compiling, so I was debugging that rather than adding features. But I do want to make that a feature where you can connect up to it and easily just drag files on it. If you're not that tech literate, I want it to be easy to use as well.
Do you think there's any reason making it cheaper now that you've made like the baseline?
So the problem with accessibility to tech is the only way to make a product cheaper is to mass produce it. Now the problem with that is accessibility tech is a niche. It's a minority of the market. So if you have 200 units that cost about $240,000 to make, and you're making like a $10,000 profit, you can't even pay your employees most of the time. Like it's difficult to make a product in this industry because it's such a minority of the market. It's not worth it for a lot of companies to go into.
Okay.
So we can't clean up all the epoxy in the garage.
So this was a long game plan. I let it sit so that I can peel it up. Any more questions?